Hello everyone. So this is going to be the last video lecture of the semester. So I'm going to keep it really short and just give you another example of working with classes in Java. And some new things that I'll discuss are static methods, static members, and default values in Java. But it'll also serve as just giving you another small example of how to work with classes and objects in Java. Okay, so I already have some code written out here. It's not much. I'll walk through it quickly. So I have this Java 3 class that's named after the file and all it has is our standard main function. I'm creating a new instance of my own class called Angle. So Angle represents an angle in degrees, so 0 to 360 type of class. I'll walk through it in a second. And then I'm printing out the value of what this object's current angle is. So I'm calling a getter get angle on our object A and printing that out. And so if we jump into this class angle, it has one member, which is the actual angle value. So it's private. I'll explain that a bit more in a second. And then we have a setter and we have a getter. Okay, so this whole class is really just wrapping this double value here, which is the angle. We set it to private because we don't want invalid values for this angle. We want to be able to control how it gets set and how it gets read, which is why we do the pattern with setter with the set and get. Okay. And so I think this is kind of a very simple example of why you might want to use a setter instead of just leaving it as public. Because there are times when setting a member to public is fine. But in this case, so we have this function setAngle, and whoever calls this can pass in a double. However, so we want to do some validation, or not validation, but we want to do some a bit of manipulation on this value. So any number that can be passed in is valid. So you can pass in 1,000 or negative 10,000, it doesn't matter. All of those are as long as it's a double, it's a valid value. But we want to do some modification to it. So if you read the comment here, we want the internal angle value to always be between 0 and 359.9 repeating. Okay, so it's 0 to 360, omitting the 360. And so how we're doing that is we're just going to do mod 360. So if you give 360 mod 360, then our current angle is 0. It means that we just went in a complete circle. If you pass 720 here, it would again be 0 because you just did 2 complete circles, but the current angle is 0. And it works with negative values too. So if you do negative 360, it would be 0. And so this is a very simple case where you might want to do a setter, okay? Because if you don't have the setter, let's say we just made this public instead, and you can set angle to whatever you would like, then that means any class or object or function that interacts with angle has to do this on its own. And so you're going to have this redundant code everywhere where you need to do make sure that the value is mod 360. Very, very easy to mess that up, probably by accident, in which case you're then going to have an invalid value, although the compiler won't tell you. And the rest of your code probably assumes that the value is going to be between 0 and 360, right? But because we use this setter, we can guarantee that the value is always going to be in this range, and we can organize our code based on that assumption. All right, so it just makes things a lot easier. And we could also do other things with it too. We could throw an error if we don't want like a negative number, but negative degrees are generally acceptable. We could count how many rotations have been made. So we would do we would do a division here and keep track of how many total divisions have been made, or how many rotations have been made. So every time you go over 360, you would increment by 1, or every time you go past negative 360, you would decrement by 1, that type of thing. But in this case, we don't care. All we care about is this number. So let's go ahead and run this, and this will show another example. So the angle is 0.0. Now you may notice that we're not actually ever calling the setter, and we have not defined a constructor, so it's using the default constructor, which does nothing. And yet this angle value is 0.0, okay? This is because Java, unlike C or C++, has this concept of default values, where every primitive type in Java, you can look up a table in the documentation, they all have a default value. For numbers, it's going to be 0 or 0.0 or whatever. It's effective. It's basically 0 for all number values. I think for string, it's empty string, that sort of thing. And so, yeah, so you need to know that you don't necessarily have to initialize all of your variables, like with zeros, which is a pretty common thing to do in other languages. Java defaults to it. I like to be pretty explicit and never allow that to happen. Sorry, my dog is attacking me. Let's go ahead and set a value and just verify that our code works. So if we do 350, it should print out 350. Okay, we printed out 350. Now, if we do 370, what's it gonna be? Remember mod 360, so we're gonna go in a circle, and it's gonna loop back around to 10, all right? And so if we do, let's see, I played a lot of Tony Hawk back in the day, so I'm pretty good with these numbers. Yeah, so 720 would be 2 complete spins, and so we're almost to that second rotation. And if we do 720, then it would be 0. All right, see, we're back to, and then you can do 1080, and it would be 3 circles. But let's just leave it at something like that, okay? So that's hopefully a better explanation as to why you might want to use setters and getters. And a quick explanation of default values. So just because this is private doesn't mean that angle isn't there, so we can't access it directly from here, but it's still there. And the compiler actually even will let us know that it's there, we just can't access it. It'll give us an access violation error if we try to like print it out directly. Okay, let's go over static. So static is a special keyword that you can apply to my dog's deciding to eat food right behind me. We're gonna make it public. So we're gonna make what's called a static method now, and then we'll get into exactly what that means. Degrees to radians. For a second, I'm just going to type return 0. Okay, so let me explain what the static keyword means first. So, oh, my dog is chewing right behind me. Okay, so what the static, hey mister, why don't you come here, buddy? Come here. Why don't you sit down right there. Good job. You're going to hang out for the lecture. Okay, stay right there. I'll give you a snack in a second. No cheeseburger. No, we're doing Java. Okay. So the static keyword, what it means is that this is I think some languages call this a class member instead of an object member. So like this set angle, we call it on an object, okay? We call it on A. This method, you will not be able to call it on A, but rather you're going to call it on the entire class. Okay, so this is very useful for utility-like functions, which is what we are making right now. So hopefully this makes sense in one moment. What is it, math at pi divided by 180. Okay, so this is a utility function that I made that will allow us to convert degrees to radians. But it takes in a parameter, the number of degrees, and it returns a value. So it's not dependent on any state information from an object, unlike a normal method. Normal methods act on an object. A static method acts on a class. So let me show you what I mean by that. So how you call it is instead of typing A, which is our object, you type the class name, and there it is, degrees to radians. And you type in, we'll type in 1 so that I make sure the math is right. It should be like 0.17 or something. And we need to print it out so that we can see it. Oops, I totally messed up the code. Okay. So we are calling our static method. It's static because it's operating on the class and not on an individual object. So, you know, we could create another angle here, angle B equals new angle, and then B dot set angle to 10. All right, so these are two methods that are acting on individual objects. They're their own separate objects. And then we have this method that's in the same class, but it's not acting on an object. It's acting on the class itself. And so that usually just means you're not dealing with state information, but it's not always true. So let's run this though. Okay, so it is printing out. Let's print out something a little more helpful. 1 degree. This many radians. Okay, rerun it. Mr. Come here, buddy. Okay, so we get the answer that I expected, and that's an example of a static method. All right, so you can put it in a class. It's usually related to the class. But it's some kind of utility function is generally what I've used these for. So in this case, if you just wanted to be able to generally convert, then make it static. It's not dependent on the individual object's angle, which could also be useful. Depends on how you want to use it. So a lot of the standard library functions are probably going to be static. Like a lot of the math functions inside of Java, I bet are static because you don't have to create an object of math. You don't have to instantiate it. Okay, so hopefully that makes sense. It allows you to call a method without creating an object of that class. And you can also do it, we'll make this public static int yeah, we'll do. Okay, so you can also create static members. So this is a variable that is shared across all the objects, okay? Or maybe that's not the best way to say it. It's a class member rather than, so in this case, A does not have its own copy and B does not have its own copy of this member. It's shared across all of the entire class. Now, why would we want to do that? Well, there's some information that might need to be shared across all objects. I will show you an example. Let's create a constructor for angle. It's not going to do anything except our class is going to have this static integer, which is going to start at 0. And every time we create a new angle, we're going to increment the number by 1. So all this is doing is keeping track of how many times we create objects of angle. All right, so here, after this, it would be 1. After this, it would be 2. And after this, it would be 3. All right, so every single time that we do new angle, it's going to increment this number. Let's print it out. It's public, right? Yeah, it's public. All right, you probably wouldn't want that to be public because that means anybody can write to it as well. And we don't want to set it, we want it to be tracked by the constructor. Yeah, let's go ahead and run it. Number of angle instances, 3. All right, so that is just one example of a case where, or a way that you can utilize a static member. So again, you use the class name here and not the objects. So it's not A, B, or C, but rather it's the class name, which is angle. Same with our degrees to radians. We don't have to create an instance to use these functions. All right, and show new setter, a getter, a static method, a static member, and how to use all of those. All right, so I wanted to keep this short. Hopefully those are useful. Let me know if you have any questions, and I will see all of you hopefully in the fall, except for those who are graduating. So have a good summer.